Let's try and make minus 23 into a 2's complement binary number. The first thing we need to do is make the number negative. And to do this, we need to put a 1 in the minus 128 column. Let's stop for a bit and absorb this. Our rule is that a negative 2's complement number will always have a 1 in the minus 128 column. So right now we have minus 128 since we have a 1 in the minus 128 column. We then need to add to minus 128 in order to get to negative 23. Now we need to add to minus 128 to get to minus 23. The difference between minus 128 and minus 23 is 105. So using 64, 32, 16, 8, 4, 2 and 1 columns, we need to make 105. Since minus 128 plus 105 will give us minus 23. The outstanding 105 can be made through 64, 32, 8, and 1. Let's fill the rest of the columns with zeros. That's minus 23 in 2's complement. If we add up the columns, you'll see that we have minus 128 plus 64 plus 32 plus 8 plus 1, which gives us 23. Therefore, minus 23 in 2's complement binary is 1, 1, 1, 0, 1, 0, 0, 1. Let's talk a little bit about the range of numbers we can represent with 2's complement. You'll need to know this for your AS. You may have noticed that by changing the 128 column into minus 128, that it changes the range. This is due to the fact that we can now represent negative numbers. The smallest possible number we can represent, i.e., the most negative number, would just be 128. We'll put 1 in the minus 128 column and zeros elsewhere, since we don't want to add anything to minus 128, otherwise the number would become more positive. So our smallest number is minus 128. So how do we find our largest, i.e. most positive value? Let's remember our rule from before. If a number is negative, it will have a 1 in the minus 128 column, which infers that if it's positive, it will have a 0 in the minus 128 column. That means to find our largest number, we'll put a 0 in the minus 128 column, and then we'll just put 1s into all the columns which are positive values. That means we'll have 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals 127 as our largest number in 2's complement. So if we have n number of columns, the range of numbers we can represent with 2's complement is from minus 2 to the power of n minus 1 up to 2 to the power of n minus 1 minus 1. Let's take a look at our smallest number here. We'll have minus 2 since binary is base 2 and we're representing a negative number. And just as the case is with normal binary, it will be to the power of the number of columns but minus 1. It is minus 1 because we've effectively lost a column because we now have that minus 128 column. Now that's all done, we'll take a look at our largest number here. And our largest number will be positive 2 to the power of the number of columns minus 1. But this time we minus another 1. Remember, this orange minus 1 is outside the parentheses. Always apply your PEMDAS rules. We minus another one because our largest number, as we've showed before, was 127, which is one less than 128. So we end up with this formula for 2's complement. You can now substitute the numbers of columns you have as n to this formula, and you'll be able to calculate the range of numbers you can represent with 2's complement. If we had 8 columns, we'd have minus 2 to the power of 8 minus 1 to positive 2 to the power of 8 minus 1 minus 1. If we simplify that, we'll get minus 2 to the power of 7 to positive 2 to the power of 7 minus 1, which evaluates to minus 128 to 128 minus 1, which is negative 128 to 127. Let's do a quick recap. We know that 2's complement numbers have the most significant bit, i.e. the column furthest to the left flipped into a negative number. All negative 2's complement numbers have a 1 in the negative number column. How to construct a negative number in 2's complement. The range of numbers we can represent in 2's complement. Thanks for watching and see you in the next video.